we'll be seeing the next locking technique, that is the two-phase locking. So in previous video we had seen the binary locking and shared and exclusive lock. So in this we'll be seeing the next locking technique, two-phase locking. So why the name two-phase is coming and all, let's explore. So according to two-phase locking, the change or the mechanism over here is, say we need to say transaction 1 needs to access data item X and Y for it to complete. If so, what it does is it acquires lock on all the objects that it requires to access before doing or starting the transaction. That is, like, it needs X and Y. So in the first phase there are two phases actually. There we have a growing phase and we have a shrinking phase. So in the growing phase we actually lock all the objects that are required to complete our transaction. So as you can see in the figure, the time starts and we keep on acquiring each lock one by one. Say if we require 3 objects to be accessed, we acquire the lock for first object, then acquire the lock for second object, and if there are n objects we require in the transaction, we acquire lock over all that object. Now acquiring lock means if we lock that item, no other transaction would be able to read or write that item. So once we acquire all the required locks, we require a locked point. So this locked point is reached once all the objects that are required to complete the transaction have been acquired using lock. So after we have reached the lock point, the operations are done. All the read write operations are done. That is what you see between these two arrows. Then once all the operations have been done, and when the operations are being done, we say the database or the transaction is in a locked phase. So we have a growing phase, then we have a locked phase where all the operations are being done. Once the operations are completed, the locks can be released one by one. So that is the stringing phase. So in the stringing phase, the locks are released one by one. So the thing to understand over here is this operations or the locked phase begins only when all the required objects are locked. And once the locked phase or the operations are completed, we start releasing the locks one by one. So as we just saw, there are two phases, the growing phase and the shrinking phase. So in the growing phase, a transaction acquires all required locks without unlocking any data. So keep that also in mind. So when the locks are being acquired, till we reach the locked point, no locks are released. The releasing of locks or unlocking happens only after all the operations are done. Only then we start releasing the locks. So once all the locks have been acquired, the transaction is in the locked point. Then in the stringing phase, a transaction releases all locks and cannot obtain any new lock. So in the stringing phase, it is for releasing the locks, and in that stage we don't acquire any new locks. Then another thing to understand is two-phase locking guarantees serializability, but it doesn't prevent deadlocks. So keep this in mind that in binary locks and shared and exclusive locks, they didn't guarantee serializability nor did they prevent deadlocks. Now serializability is guaranteed by two-phase locking, but deadlocks cannot be prevented even by two-phase locking. So you may get questions like justify two-phase locking guarantees serializability with an example and all. We'll be shortly seeing an example for the same. So some rules that two-phase locking protocol follows are two transactions cannot have conflicting locks. That is one thing. So if we are following a two-phase locking protocol, never two transactions can have a conflicting lock. Then no lock operation can precede a no unlock operation can precede a lock operation in the same transaction. That also we saw. All the locks are acquired, only then the operations begin. So once the no unlocking operations should happen before a lock operation happens in that transaction. Then no data are affected until all the required locks are obtained. So these are the features of two-phase locking protocol. Then there are certain drawbacks of two-phase locking protocol. One is two-phase locking increases the transaction processing cost, because like we are waiting, maybe we may have to wait a lot amount of time to acquire all the required locks. And when we lock and keep certain data items, those data items cannot be used by any other transactions. So there's time involved in this. Then another drawback is like the possibility of creating deadlocks. So I'll just briefly explain what a deadlock is in the context of database. So imagine we have two transactions, T1 and T2. So and imagine T1 and T2 both are following this two-phase protocol. So T1 is actually doing a two-phase locking protocol, and it needs to acquire lock on say R1. R1 is a data item like X and Y and Z. Say in this example R1 is a data item. So T1 to complete its process, it needs to acquire lock on all the objects it needs to update. So it is waiting for a lock or trying to lock R1 because it is waiting for the lock because that R1 is being held or locked by T2. So only when T2 releases that R1 or unlocks that R1 can T1 access that R1. But unfortunately now T2 is also doing this two-phase protocol, and for it to do all the operations it needs to acquire a lock on R2, which is unfortunately locked by T1. So now T2 is waiting for T1 to release R2, and T1 is waiting for T2 to release R1. So T2 will release say R1 only when it gets a lock on R2 and completes its process, and T1 will release T1 will release R2 only when it gets a lock on R1 and it is able to complete. So not, this is a deadlock situation. Now T1 will do something only after T2 does, or T2 will do this only after T1 does. So they are in a deadlock, and there are different mechanisms to overcome this actually, and you might have learned all the mechanisms in operating system. So actually deadlock cannot be prevented by two-phase locking protocol, but we can achieve serializability. Then you can expect these kind of questions, that is, does the transaction ensure two-phase locking protocol? You will be given two transactions like T1 and T2, and now in this you are asked whether this transaction ensures two-phase locking protocol. So for to answer this, you should be knowing what two-phase locking protocol is, and you should be in a position to check the transaction commands and see whether two-phase protocol is followed. So let's see how to evaluate such a question. So in this, first we have a read lock. So this means read lock is issued on Y, and we read the item Y and we unlock Y, and then we issue a write lock on X. So now if you had listened properly, you might be knowing that this write or this lock cannot precede an unlock. Why? Because in two-phase locking protocol, all the locks required are acquired first, then we do the operations, and only after the operations are completed we start unlocking the objects. But in this unlock happens before this lock. So this is not ensuring two-phase locking protocol. Over here also in T2 also we unlock X and then issue a lock over Y. So with that itself we can say this doesn't ensure two-phase locking protocol. Now if we are asked to convert this transaction into a form that ensures two-phase protocol, this would be the answer. So just pause over here. This is the original transaction. Now we'll be changing some order, that is, we know that all the locking operations should occur first, and only then unlock should begin. So this write lock should happen before this unlock, so keep that in mind. And over here also this write lock should happen before this unlock. So to achieve that, we'll be changing the order of commands within the transaction, and this is the answer. So in T1 dash it becomes, we do a read lock on Y, we read Y, we issue a write lock on X. After that we can start unlocking, because at this stage X and Y were required to be locked, that we have achieved. So once we have locked all the things we know, then unlock can start. Then the operations are done. Over here also this all the required locks are acquired first, then only unlock can begin. So this is how we can ensure this transaction follows two-phase locking protocol. Another question you can expect is this. Now this is a university question asked. So the question was like, you are given a transaction over here, T0, T1 are transactions, and now this question actually combines two topics. This combines serializability topic as well as this two-phase locking protocol. So this question can evaluate whether you have understood two topics, serializability and two-phase locking protocol. The question is like, is the transaction serializable? That is the first part. Then you are asked, if not, that is if it is not serializable, ensure serializability using two-phase locking protocol. So first, to prove or show that the transaction is not serializable, we should be drawing the precedence graph, and in that precedence graph we should be getting a cycle. Hope you remember that process. So if we get a cycle, we can say it is not serializable. So let's see or draw the precedence graph for this transaction. So after this, T0 is the transaction and T1. It is not T1, T2, it is T0 and T1. So R0 means write on A by transaction 0. So W0 on A means T0 transaction is trying to write upon A. And over here, T1 transaction is trying to read A. So these two are conflicting operations. So you should be aware of how to check conflicting operations. So these are conflicting operations. So we will be having an arrow from T0 to T1. So that is how this T0 to T1 arrow came. So and you can justify why that arrow came. It is because of W0A and R1A. It is because of these operations. Now another conflicting operation we have over here is there is W0B over here and R1B over here. And this T1 is trying to read B, and over here T0 is trying to write B. So we have a conflict. So we will be having an arrow from T1 to T0. That is how this arrow T1 to T0 came, and they have written the reason for that. It is because of R1B W0B conflict. So we have shown that it is not serializable. Now our task is to show or modify the transaction in such a way that we apply two-phase locking protocol and show that it becomes serializable. Let's see how that can happen. So how can we issue locks? So in starting over here, it is read A. So even before read A occurs, we should be locking A. So that is how we can issue a lock. So just before showing you the answer, we can have a discussion using this slide itself. So now imagine we lock A. So we have kept lock on A, and lock on A won't be released until we complete the operations. So we can lock A, then we can lock B, only then we will be starting to unlock A. So till then this A cannot be or should not be accessed by T1. So if this A is locked in this stage and then this operation comes, that is T1 tries to read A, it won't be able to read A. Why? Because it is locked by this transaction. So it would have to wait until that lock on A is released. So hope you get the picture. Let's see the solution now. So L0 means lock operation by transaction 0 over A. So we lock A, then we read A, we write A. So after write A, actually this read A is occurring in T1 according to this schedule. But now this A is locked by transaction T0. So T1 won't be able to access A because it is locked by transaction T0. It would have to wait until it is being, this lock on A is being released by T0. So this first like before this T1 tries to read A, it will have to acquire a lock on A. Think in that manner. Before this T1 tries to read A, it needs to acquire a lock on A. So at that stage, T1 comes to know that when it tries to acquire a lock on A, that is L1 of A, that locking mechanism will be blocked. Why? Because that lock is held by T0. So it will have to wait. Then what happens at this side is we lock B, read B, write B. After that, all the procedures are over. We unlock A, we unlock B, commit the transaction. So at this stage, when A is unlocked, maybe internally the transactions may be communicating using some messaging protocol and all. A message would be sent because over here T0 knows that T1 is waiting to release a lock on A, or it is trying to issue a lock on A. So once this lock is unlocked, now T1 can lock A, and so the lock is granted at this stage because it is released at this stage. So T1 is granted a lock on A, then it can continue. So what happens over here is then they read A, lock B, read B, unlock A, unlock B. So over here you can see only after this transaction commits, this transaction begins. So in this there won't be any cycle. You can actually try drawing the precedence graph. You won't be getting a cycle. Just try to draw the precedence graph of the schedule. There won't be any cycle. So that is how you can prove that this schedule initially it is not serializable because we are getting cycle in the precedence graph. Then you need to show how you can apply locking mechanism, and this transaction is kept to wait because of the lock on A. And then actually you need to draw the precedence graph for this schedule, and there won't be any cycles, and you can prove that you are achieving serializability by ensuring two-phase locking on the schedule. So hope you understood that example. So that's it regarding two-phase locking. Now a bit of theory is left in two-phase locking. So the two-phase locking we just saw is conservative two-phase locking. Two-phase locking, the short form is PL, or static 2PL. There are two more versions. One is strict PL and we have rigorous 2PL. So let's have a look at what is strict PL. So strict PL is something that guarantees strict schedules. Hope you remember what a strict schedule is. Like if we are trying to read or write a data item that has been written by some other transaction, that transaction should have committed, only then we can read or write that particular data item. So there was a definition for strict schedule. So this two-phase protocol actually guarantees even strict schedules. The ordinary two-phase locking doesn't guarantee strict schedules. It is the strict two-phase locking that guarantees strict schedule. So how what is the variation is like a transaction T does not release any of its exclusive or the write locks until after it commits or abort. So in ordinary two-phase locking, it's like once the operations are completed, we don't wait for the transaction to commit. We start unlocking the things we have logged. So in order to achieve a strict schedule, what we do is we when in the unlocking phase also we do not release the exclusive locks, that are the write locks. We do not release the write locks. The write locks are released only after the transaction commits or aborts. If this additional variation is bought, it becomes a strict two-phase locking protocol. Now let's see what a rigorous two-phase locking protocol is. This also guarantees strict schedule. Now the variation is a transaction T does not release any of its lock. Let it be exclusive or shared. No lock is released until the transaction commits. So these three difference should be clear to you. In ordinary two-phase locking, once the operations are completed, we can start releasing the locks. In strict two-phase locking, once the operations are completed, we can start releasing the locks, but the exclusive or the write locks are not released until the transaction commits or aborts. In rigorous two-phase locking, the locks are not released until the transaction commits or aborts. Neither the shared nor exclusive lock. No lock is released in rigorous two-phase locking. So hope that variations of two-phase locking is also clear to you. Thank you.